Hi, everyone. Our next presenter, Nick Van Weerdenberg, is the founder and business development leader of Wrangle.io. He's a firm believer in the thin server, full JavaScript stack, and is an evangelist across the Toronto tech community for this. Here this afternoon with his presentation, Continuous Deployment Workflows for Non-Trivial Full-Stack JavaScript Applications. Please welcome Nick.
So I changed the title because I was out Thursday night and a couple of people were making fun of me because the title was a bit long. So this is a little more elegant, Continuous Deployment Workflows for Modern JavaScript. Now there's a lot of really great talks on YouTube and a lot of really brilliant people in this space. I'm not one of those, but what I can talk about is sort of all the things I've screwed up over the years and all the challenges I've had and sort of what we've learned about making it work. And hopefully that will be an interesting talk. So I've had 18 years in the software industry. I was an early adopter of Agile and iterative development in 2001. And at the time, we were doing the rational unified process. And every time we really screwed that up, we started calling it extreme programming. And that's how I learned about extreme programming. And it was about 6 months after the Agile Manifesto was signed, I think in Denver. I've applied Scrum to marketing as well as software development. I went sideways for a little while there before I realized that I didn't want to be a marketer. I spent 3 years working for software companies that actually worked in manufacturing. So I worked with a lot of really brilliant Lean Six Sigma people who worked in production, understood the whole Toyota production system. And it was really interesting to see that start moving into the software development sort of theory with lean development and Kanban boards and whatnot. I spent 1 year actually working in a plant that did a lot of Six Sigma programs and 2 years selling Lean Six Sigma software and working with a lot of consultants in the industry. And it's remarkable in that if you think about it, just in terms of like process and minimizing variation and all the little things that go into manufacturing, even like 30 years in, North American manufacturers still can't really get it right compared to the Japanese because there's a lot of really subtle, important things that you truly got to grasp. And quality, continuous improvement, pushing that to the front line, and really embracing things like value stream mappings, optimizing the system, small batch sizes. And the big telling thing still is that when Toyota would have a problem, they would stop the production line and they would fix the problem. And so that got everyone really focused on quality, that got everyone really focused on the process, and that really drove continuous improvement. And we've seen companies do that now with continuous deployment processes. So for instance, GitHub would push multiple times a day to production and run with only 2 branches, whereas most people would run with 3 because they'd want to do their staging and their testing. And if it fits your risk profile, being accepting of those small breaks in production will drive your continuous improvement so much faster that you'll get less failures in production ultimately than you would if you didn't enable that. And so that's sort of the counterintuitive leap of faith that the Japanese manufacturers took and North American manufacturers are still struggling with. And we're seeing the same thing in the software industry. And so yeah, as in the intro, I run a full stack JavaScript consultancy. And our philosophy is to focus on a very narrow set of technologies and become extremely good at them. So we want to be as good as anyone in the industry in what we do. So we have a narrow selection of technologies that we work with. It's not really to demean any other technologies. It's just we're not going to expand our technology footprint unless we can also be masters of that technology. So we focus on AngularJS, we focus on PhoneGap, we focus on HTML5, MongoDB, and that stack, largely so that we can get the best practices and apply them to our customers and to our projects. So our main philosophy is WWTJHD, and this stands for what would TJ Holowaychuk do. But you could also insert Douglas Crockford, except he's a little grumpy sometimes, or any of the luminaries in the JavaScript industry. The thing that I really love about the JavaScript sort of community, for a language that's so demeaned, there's so many brilliant people working in it. And a lot of them have come out of functional programming, out of the Clojure community, and it really makes for some really rapid progress in the industry. And so we always look to best practices and standards and try to adopt them. So today I'm going to talk about what is continuous delivery, go over a continuous delivery maturity model, and talk a little bit about continuous delivery processes and tools, and sort of what our journey's been adopting it. And I guess first off, what is continuous delivery? I find the best way to think of it is a deployment pipeline that reaches from the developer's machine to the production server. And people who've really embraced it completely have no barriers to that. So your developer can actually push changes into production. It's also the value stream and the quality strategy that allows continuous frequent delivery of features through that pipeline. And if you look at lean manufacturing, some of the strategies that sort of emerged there and have permeated all manufacturing and that are being adopted in software delivery is you minimize inventory, you minimize work in progress, you minimize and eliminate waste, all via a continuous improvement process of the entire value stream system. And it's a lot of words, but it really just, continuous improvement is the fundamental sort of goal and the fundamental process there, and always having things move forward. Has anyone read this book, The Phoenix Project? I'm just curious. This is a novel about DevOps. So if you can believe that such a thing exists, it does, and it's actually a really good book. It's written in a story, and it deals with a manufacturing company and all the challenges they have delivering projects, managing work, and it's a fun read. So it's also very well regarded on Amazon.com. So if you ever, I'm sure you've always dreamed of reading a book on DevOps, so there you go. History of continuous delivery, I'm not going to go into this, but a lot of it emerged with Flickr. GitHub did a lot. Etsy's very famous for that. Some of these companies have over 200 commits that are getting pushed into production a day. What a lot of companies are doing is they're turning their production deployment process into A/B split testing. So taking things from marketing, so they'll actually deploy features and they'll run them with a subset of customers, and they'll see how people are using it, whether they're getting confused. They'll pull metrics from the interaction with the software, and then they'll decide whether to keep that feature and roll it out to the rest of the user base or revert it. And I've met some companies in Toronto that are making really interesting decisions in terms of their technology stack, not based upon throughput or productivity, but for the agility they can build into their complete end-to-end process. They want to quickly, frequently deploy, test, get feedback, and adjust their product strategy based upon that. So, going beyond just testing the code to make sure that it works, but they want to test it to make sure that it works with their actual customer base, and that's pretty amazing. So some of the keys to continuous delivery is learning to recognize sources of waste, and this is not at all intuitive or counterproductive. This is something that the Japanese discovered in manufacturing, and they used to almost destroy North American manufacturing because they realized how much waste they could remove from the system. At one point, it took Toyota something like 25% of the man-hours to build a car compared to General Motors. And if you think of that, that's a stunning sort of figure. It's just mind-blowing. And a lot of that is understanding all those, like what task switching costs, what an error costs, what inventory costs, and what work in progress inventory, what the costs are, and adding them all up. It's really hard to do, but if you tackle it through a continuous improvement process, you'll continually see the benefits. So Poe's law is basically that any statement by a zealot or any statement that's very passionate about a particular topic in a news group can't be distinguished from basically humor if you don't have the surrounding context, because you can be talking about continuous delivery and say something like I have there on value stream mapping, and you can't really tell out of context if that's satire or if it's actually a real statement. It's a little bit Dilbertish because you get so many sort of buzzwords in there, but it is well based upon lean manufacturing and validated in industry. So I left it up there. Some of the things that really drive that end-to-end system. This is the model that the Japanese came up with, and obviously not in English, and this is the best we can do to match up with it, but sort of what the method of doing the work is, what the manpower is, the team doing it, what the machine is, the materials, and then measuring it for continuous improvement. And in software, we have some things that match up with that. What's your software development life cycle? What's the experience, training, and responsibilities? What are the tools? And what are the, oh, I got a little typo there. Specification, I don't know what that was. Specifications, tasks, features, and tests. And what's your measurement? And this is interesting when you look at the whole picture, is sometimes it actually makes sense to have two people on one machine in a process, and they're spending most of their time standing around. But you need them there because they're really maintaining the flow of work through your system. And so maybe they're doing the changeover. Maybe they're doing sort of the final test. So in a lot of organizations, we won't hire a tester because it doesn't make sense from a capacity perspective, right? So you're paying this guy, and you're paying him a lot of money, and he's only working like an hour a day to test what's going into production. So you can't justify it from a capacity perspective, but you're not looking at the whole system, right? If you have a guy who's responsible for testing and deploying into production, even if he only works 30 minutes a day, that enables the flow of work through your entire system if you're optimizing the entire production process. And that has a huge impact. And so you don't want to just look at the person and do the calculations on a napkin and say, well, we can't afford that, we're going to have someone else do it, but look at the impact on the entire process. And that's what this gets at in terms of like looking at production and looking at processes. A lot of the innovation in Japanese manufacturing was actually switching over tooling for different vehicles so that they could reuse plants and optimize the process. And there's I don't know the specific details, but there was this one thing for stamping hoods on Japanese cars that took like 2 days to change the dies. And so they could only do huge batch runs, and because they could only do huge batch runs, they had more work in progress, more errors, and they really had to do things that weren't optimal for customer delivery, but were more optimal for manufacturing in the process constraints in the process. And so they just kept at it, kept at it, and kept at it until they got it down to like a 10-minute change. And they spent a lot of money investing in building things so that they could get rid of that one critical constraint to allow them to have that lean sort of manufacturing process. And I think a lot of things are similar in the software realm. So waste is one of the key things that people discuss a lot in Lean, and what are sources of waste and how can you eliminate them. And so in software, rework is obviously a huge waste, but it can be a learning experience, and so it's the amount of rework, right? So with agile development, you do rework, but you do it early on, and so you get a lot of learning, so you don't end up with a pile of work that needs to all be reworked or can't be reworked, and you have the wrong product in the wrong market. And so there's the strategy around rework that drives feedback and continuous improvement in the quality of your understanding, and that drives less rework downstream. Anything that you have to do manually is obviously waste. Slow work, interrupted work. Interrupted work's a huge thing. And so if there are ways to sort of simplify and remove interruptions, and so that's where you get into sprints and having a process where people don't get distracted by changes. Feedback's the other huge thing. So you can think of the entire goal of continuous delivery and getting there and continuous improvement is looking for more feedback. And frequency of your process drives feedback. So I put together this slide just looking at sort of things that have emerged while I've been in the software community that have gone from, say, less than 25% of companies doing it or less than 50% to being somewhat pervasive. And we had version control systems. For the first 5 years of my career, every job I had, they weren't using it yet. We introduced it. Then use cases came out, becoming user stories, looking at units of functional working software as what you were speccing and delivering so you could test it and reduce risk. Incremental development, iterative development, so rational unified process as well as extreme programming, Scrum, and Agile methods. Unit testing came out of that. Agile, Scrum processes, pervasive automation. I remember getting really excited about pervasive automation like 10 years ago. Continuous integration then came out to drive more of that. And then that enabled, I think, this last sort of few steps of the journey to like a really amazing process, which would have been unthinkable to most people 10 years ago, with DevOps and continuous deployment and the understanding of the software lifecycle to be able to actually achieve things like continuous deployment. And if you look at this, the frequency of delivery has been going up, and that's been driving more feedback. And so you can think of your process, if you have something and you're not sure how to go about it, if you need to speed it up, And even if it's painful to speed it up, once you've successfully done that, all that feedback will have driven significant improvement in your understanding and in your process. It's going to drive out all the issues, to the top and get past our just sort of general, guesswork around a particular process. And so how to generate feedback. And these are things that motivate me when I'm looking at how we deliver our software. Deliver more frequently. So it's not a fad, but it's really, that's making us do everything right and understand how we do it and how we can do it repeatably. Running testing software more often, automated unit and integration tests. Planning meetings, instead of doing them quarterly, do them more frequently so you can incorporate learning. Building your environments, you learn a lot about that. I'm here talking on Wednesday night. We were doing a deployment, and we work with customers, so it's their environment, but we had to upgrade at like midnight Ubuntu from 11 to 12, and we had to upgrade Perl from 5.1.2 to 5.1.4, because somehow between Perl 5.1.2 and Perl 5.1.4, they changed how you dereference things in hashes, which is unimaginable to me. I don't know how you could do that in a minor point release, but that happened. And so to get actually production deployed, it took 6 hours, and this was like just because of new things that had come out, and they still weren't being diligent about maintaining a staging server that was identical to production, because it just felt like the last time, right? I mean, what could go wrong? We've had 3 great deployments, everything's rolling around smoothly, and then these 2 issues came out of the differences. We upgraded Node, which broke on Ubuntu 11, and then we also ran into the issue with Perl scripts. And so, and then that's continuous improvement, right? So in that particular environment, on that team, in that process, that's not going to happen again, because we are automating the building of the staging environments, and so there's never ever going to be an issue not to build a staging environment. It's not going to be like, hey, we need a staging environment. It's like, oh crap, there goes like 3/4 of my day, and you put it off. It's like, oh, we need a staging environment. You run one script, and you have your staging environment. That also becomes important for developers if you've got a larger team, because they're all fighting on the same staging environment, and then you can't actually get the testing you done. You've got a constraint on your process. They're taking turns testing, they're getting in each other's way. So if a developer is doing something that really does need to go on a staging environment, it's a major feature, it needs some, looking at by itself, they can fire off their own staging environment. That's going to be identical to production. Now you can do that through scripts on the cloud, or what a lot of companies are doing now is they're using Vagrant, and you can have developers fire up something that's almost identical to production, and that addresses a lot of those issues as well. And the thing is, it's expensive to get there, but once you're there, it's no longer expensive to do it, and then you don't run into, like, having 5 guys, on the phone for 6 hours. That's not only the 6 hours of time, it's not only the risk to the deployment, but it's also they're wrecked for the rest of the week. So, it's ongoing sort of cost that, so that was a fairly big hit for things that were completely unexpected. But that's the thing, right? It's unexpected, but it is expected because this is software. And this is where the Japanese really nailed it. They understand that variation and variability is what drives errors and drives issues. These little changes, if you get a couple of little changes, they can compound and take out, something that looks like it's mostly robust. And in any process where you go from commit to production, there's probably 20 things, maybe 30 things, 40 things that are working together. And if you have slight variations in any of those, you've got a defect and you've got an error. And hence with Six Sigma, that sort of goal to 0 defects, 6 parts per million, Six Sigma 3.4 parts per million, is that when you have dozens of things, that low failure rate is still compounding, and you're going to actually end up with failures, and the cost is significant. So, types of feedback: test-driven development, build often and automate, deploy frequently. Documentation, it's more than documents. And so if you think of a lot of what we're doing with continuous deployment is we're creating documentation in other areas. And so tests are documentation, automation is documentation, code comments are documentation, commit messages are documentation, installation scripts are documentation. And of all of these, tests are just one small part of it. A lot of people are doing tests somewhat, but they're not doing the automation, they're not worrying about code comments, they're not doing good commit messages, they're not doing installation scripts. And so the whole system, from an end-to-end perspective, the chances of actually successfully doing rapid deployment to productions is about nil without hitting a significant issue. So DevOps, is a huge buzzword, That's really being able to pull automation right back through the deployment pipeline to enable zero-cost activities across the entire value stream. So right from the code being written and getting it sort of through testing and all the way into production and driving that to near zero cost so that I could make a fix to something and I could push it into Git and I could deploy it into production and expect that to work, 99 out of 100 times. And if you're going to do that, then you need automation that one time that it doesn't deploy. If you can roll that back in less than 5 minutes, then it's not going to be a huge issue and people aren't going to be talking about it. But what a lot of people will do, they haven't automated the rollback, and that's an important step if you want to get to the continuous deployment. And so one of the big pains that we've actually had with moving to a JavaScript stack is that these things aren't really defined best practices, and there's still not a lot of tooling around that, and we still roll a lot of our own logic around schema management, schema migration, and rollback, and so we're working in that area to make that more efficient so that we can ultimately do work in environments where we would be pushing to production in areas where if we're down for 5 minutes, that's okay. If we're down for 10, it's not. And that's still coming along, I think, in the JavaScript community. So fail fast. You often get a guy who's your DevOps genius, and that's a single point of failure. And it also means that there's stuff that he's doing that's not automated. And if you're truly automated, if you truly have that sort of process in place and the documentation in place, you should be able to switch your DevOps manager every week to a different developer. And you need that level of knowledge and that level of experience in your group. And so that's a great sort of way of pushing change, failing fast, and actually seeing that you've got that environment in place. And ultimately, again, like I talked about that a bit earlier, can you have any developer commit to master and push to production? I would suggest that when you're looking at cases where you might do that, learn more about the companies that you're emulating. So for instance, GitHub, if GitHub screwed up a commit, well, they're doing GitHub, they're not doing Git, so you could probably still check out code and check in code, right? So you're not killing a development team from doing work, you're just stopping their managers from seeing the pretty graphs, especially early on. So they have an architecture that's not going to actually completely break from a failed commit, unless it has to do with their load balancing and their cold cache, like they had in April, where they ended up failing over and going down for half a day. But that was a production ops issue that was sort of outside of DevOps. Etsy, I don't know much about Etsy's architecture, but I imagine that when they're pushing code, they probably have some stuff that's not going to, an architecture that's not going to completely, decommission them if something doesn't go right. So I guess, advise against blindly trying to do something like that without really knowing what the cost is to you and how people are doing it successfully, because there's usually a lot more to the story in the background. So feedback and automation, they're also the enemy of entropy. If you aren't improving, you're getting worse. Like, I don't know how many people, you have something that's been working great for months, you don't look at it for a month, then you have your staging environment and you thought it was perfect, and it's not, right? So similar to the issue that I had last week on Wednesday. It was good at one point, but it's no longer good, and that's entropy. Things are starting to fall apart slowly. That's because we don't rebuild it, we've built it once, and now we don't want to get back to it and touch it. So if we had automated that, and we were sort of always firing up new staging environments and always refreshing them, and we kept improving that process, then that wouldn't have happened. And entropy destroys software, and it destroys software processes both. So people go back into code here and there and make a few changes. We got a code base from a customer that we took over, and there's a line of code in there where it's user.isSteve. So when this code runs, it knows if it's Steve running the software, and it does things slightly different. So that's entropy, at work there. Automation. Oh, I still couldn't believe that. User is Steve. So automation. There's probably a good reason for it too, but then it's still there in the code base, right? They forgot to take it out. So it was probably for a demo for an important customer. Automate everything. Increase the frequency of everything you can. Automate everything that can be automated to allow cheap iterations and faster cycle times. Automation equals knowledge equals documentation. And I think entropy is a great concept because you can see that all the time. As soon as you stop improving, things slowly start getting worse in your architecture, in your processes, in your environments. So how to get there? So this is sort of phase 2 of the talk. I talked a fair bit about this, but I'll sort of speed it up a little bit. So after going through this on multiple projects with multiple customers and trying to bring, we often work with external developers, so we're trying to bring them onto a new process. And depending on their background, sometimes it's extremely hard. You know, one thing that we have learned is that you cannot underinvest in Git training because everybody assumes Git's just like Subversion, and oh my God, the things that happen. I mean, wow. And things that I've even done. So I went onto a developer's machine, and she had been on Subversion and loved Subversion, and she'd been happily working and committing and committing and committing, and she sort of forgot that she was committing to her local repository. And she was not going and pulling updates because she sort of thought that she was getting that on her branch, I think. And so I didn't realize that her master branch was like 6 weeks behind the server. And she had pushed her feature branch onto the server, and there was no way to rebase it, so we'll talk a little bit about that. But rebasing is where you take your changes on a feature branch and you replay it back on the master so that when it gets merged, finally, it's like you wrote all that code. You wrote a week of code in like the last 4 minutes, and it's on the exact last version of master, and the guy who's reviewing it can just merge it and everyone's happy. There's no conflict hell, no merge hell. Like Git rebase is amazing. And so I did this. This is what I did, is I did git push -f and went into master, and I looked at master and it's like, wait a second, that doesn't say November, that says September. And we'd actually, you know, it gets wonderful because it's just a pointer, right? So the pointer got moved back, so it took about 3 minutes to fix and move the pointer back up and have the rest of the repo there, but I was completely terrified for those 3 minutes until I figured out what had happened. We had like 6 people working on it, so I'm thinking to myself, somebody's got, you know, master from this morning, so it's not that bad. But yeah, and so there's another configuration setting that you can make in Git so that when you do a push from a feature branch, it doesn't also push master at the same time. And we had that on every machine but hers. So I got to figure a way to automate that so that doesn't happen again. Git's fixing that in a later version. I think that's fixed in 1.8 or something like that. So we'll move there fairly soon. So phase 1 activities. So TDD, you know, source control and issue tracking. Everyone's good with that. Tests, everyone's good with that. Continuous integration. You know, most people are going there. Surprisingly, not as much. I think because it's still a bit of a pain to set up. Jenkins is bizarrely horrible sometimes to get working. Automation of deployments, rare. Lots of people still, you know, secure shelling into a machine and pulling. And then even if you get through all this, so you've got continuous integration, TDD, trusted source control, automation of deployments, you're still really nowhere near continuous deployment. And a lot of companies, they try to rush the next step and that they hit a wall. And so I'd say this is 3 to 6 months. All of this is pretty straightforward. You get Jenkins installed, you push people, you put a few gates in place, and you're all good, right? This is easy. You write the test first. So this is something that I found very helpful for the automation part of it. So I, at one point, thought, hey, why not take a test-driven approach, but from a scripting perspective? So anytime I'm setting up a server, I used to go in and set it up with Bash and get it running, and then I'd go back maybe the next day or the next week and try to write an equivalent Fabric or Capistrano script to do that. But rather than doing that, I actually sort of like, why not script first and not let myself actually run a Bash shell on a remote machine myself and do everything using Fabric and building it. I like Fabric, so building out the environment. We do smaller scale production stuff, so I don't really know Chef or Puppet, so I just play around with Fabric mostly. Pair programming on the challenging parts. Like pair programming on challenging code is awesome. I think it should be done a lot more. Pair programming on other code, not really so awesome. There was an interesting study by, I think, or it was in a book I read, by Barry Baum, who did a lot of the iterative sort of software development lifecycle stuff, and that code reviews have almost the same impact on defect rates as unit testing, because unit testing is never going to give you full coverage and full logical coverage. And actually having someone sit and go line by line and review code with you and give you feedback, and doing things like looking how complex it is, how many paths there are in a function, smaller functions, and other metrics. Nothing to do with tests. You can get the same feature defect rate using that, which is pretty impressive. So if you're just doing tests, but you're not doing anything that's collaborative, you're not actually looking at the structure of the code and seeing if the code's well structured and running metrics against that, looking for structural issues, then you still are entailing a huge defect rate that's probably the equivalent to the defect rate that you just got over using TDD. And then increase the frequency of everything, right? So the more you do it, the more you push, and you do this continuously, then you drive the automation and the continuous improvement. So this is my process for learning test-driven development in 1 week with JavaScript. Do not write console log statements anywhere. Do not use a debugger. Because if you try to do this with JavaScript, you are totally screwed. Because you're going to make a typo, you're going to make an issue here, you're going to make an issue there, and you're not getting the type checking. And so you're going to have a really hard time unless you start reading through every line of code, and most of the time you just don't see that. I don't know if you've ever seen someone post a little snippet of code. I've been trying to fix this problem for 3 days. Can someone help me? Like 1.5 seconds. Like, dude, you're missing a semicolon. Or, you're missing a var statement. Like, I had that happen once. A guy, he spent 4 days trying to solve a problem. I swear I saw in 3/4 of a second in the code, it just jumped out to me because I hadn't seen it before. And he just kept, reading right past that. And so if you actually take a week, say a week of no logging and no debugging, and you try to actually write code that works, you're going to start really loving your unit tests, because that's going to be one of the few things that will get you actually through debugging stuff. Same thing with automation. So don't type anything in a remote shell. Do everything via Fabric, Capistrano, etc. Put your automation code in Git submodule so you can reuse across projects. One of my big issues is I feel like I've rewritten all my automation code like 3, 4, 5 times, and I just find it's been very hard to reuse it because, again, entropy sort of starts eating away at it. It's solving specific problems in another repository. But when I put it in a Git submodule and include it in my project, and now I'm sort of forcing myself to write the extra sort of pieces of code that allow me to tailor it. And so you're building your own sort of mini sort of stack for automating your particular needs. And then when you get stable, you can take that Git submodule and actually turn it into a node module. But instead of publishing it as a package, you can just reference Git in the package JSON. And so that's a very sort of helpful way to get some of your automation code shared across projects, and you get a lot more value for putting the effort in. So the phase 2 maturity model, this is, I think, the hardest part. And it can take 6 to 9 months or years or never. And because a lot of this is stuff that's not that intuitive. It doesn't seem to really impact things, but it does. And I'm sorry about the small text. I was going to try to make that a little bit bigger. But the question is, what are the chances of getting a small feature deployed to production safely in less than an hour? And that's a good metric, for moving towards continuous deployment. And the first thing is feature-based thinking. Small logical commits with good commit messages. Out of everything that I'm talking about today, the thing that's been the biggest epiphany for me in the last year is the structure of a commit, and what you can do with Git. Because if your commit is not entangled with other features, it's standalone, it's atomic, you can push it and roll it back, and it has a really clear description and a couple of other things that really enables that flow of that feature to production. But it also creates a whole collection of features that are flowing through your deployment pipeline that are all sort of rational, easy to understand, and well structured, and you can apply the rules to them a lot better in terms of like, okay, was this linted? Did they use JS hint? Is it following our coding convention? Does every sort of method or function have a JS doc or documentation comments? Are there tests? That's obviously an easy one to look quickly. But anytime I've been in a project, and maybe I'm just not disciplined enough, but when we're getting crunched and I'm getting commits coming in, if it's even a little bit complicated, but it's been rebased and it's not behind master, and I'll scan through it and I'll just click merge. I don't want to spend any more time trying to figure out what's going on. Like there's 6 features, they fixed 4 bugs, and so the unit of commit is huge. So small logical commits with good commit messages, good tests obviously, and then your continuous integration metrics. Really get into those metrics and see if things are trending the right way, because that'll give you the biggest insight into whether your commits and your tests and everything are coming together. And I find focusing on commits will often drive that more than focusing on tests. And then comfortable feature flow, so you have work in progress is managed through a real Scrum Kanban process, so people are building features, they're doing it right, they're focused on quality rather than trying to push things out, and then you slowly improve your flow, right, so your velocity increases. All features are reviewed or pair programmed, and so people are reviewing those commits when they are putting in pull requests, or if it's a complex feature, they've pair programmed it and they've had those two minds on it early on. Deployment to staging is semi-automated, so you're almost, you can just basically have pass in Jenkins, your continuous integration, and have those features automatically move over to staging if you wanted to, but you're not doing that yet because you want to control staging because you're still batching your production push, right? So you don't fully automate it because if you understand what I'm saying, if you're doing full continuous deployment, you'll just have things automatically flow to staging, QA passes it, it goes into production, it's deployed. If you're doing a QA cycle that's longer, then you're going to be batching your commits and batching your features and doing QA against that and then pushing it to production. So semi-automated is really what you want here. And then you focus on clarity, sustainability, and velocity. So flow, not capacity, and making sure things are always moving. So phase 2 activities, lots of Git hooks, JS hint, reject any commit that doesn't pass a lint and doesn't have a headline. And so that like a good commit message structure. So one of the things when you're running like log statements and a lot of Git commands, they'll only show you the very first line of a Git commit message. So one of the best things you can do is for every Git commit message, have a headline, have a space, have the body of the commit. Because now you can really start going through Git commits, now that especially that they're logical and well described and feature based, and you can sort of go through them extremely quickly. However, if you just have a Git commit that's a paragraph and it's just sort of written in any style, you're still going to suffer a lot trying to get a quick view of what's going on in a set of commits. And so that's really valuable. A single commit per pull request. And so this is where the magic of Git rebase comes into play. You can push and you can do as many commits as you want while you're developing, but if you're really doing feature-based things, then you can do a Git rebase. You can squash your commits down to one with one extremely well-written commit message, and when you do your pull request, the person who's getting it, they'll see what the pull request is. There's one commit, there's one message, it's a small commit, and they can probably in like 5 to 7 seconds know if they should reject it or not. And that's huge for the continuous improvement process and getting the people who are your gatekeepers for the quality of code going in to be able to do that without just giving up and starting to merge stuff. And then again, everyone's a Git ninja, and the commits are clear, concise, and independent. And I'd say having really solid Git training, especially around rebase, interactive rebase, teaching people how to squash commits that's probably the most valuable thing we've done in the last 6 months for improving our process. So phase 3, are you ready for multiple deploys per day? So I think this starts looking more at commits, commit sort of success, the acceptance rate, so how many pull requests are being rejected, the number of issues that you're finding on staging and production. Are you discussing getting rid of the staging server, right? Are people thinking, well, we're wasting time because we keep going to staging and it just passes and it goes off into production. So if you're getting anywhere where you're not generating lots of stuff on your release staging server, then you're looking at a place where you could potentially just, once you've passed your CI tests on your development branch, push it straight to master. And so that's a qualitative thing, but it's a pretty powerful one. What's the impact of a bad feature deployment? Can you roll it back? What exactly is the cost going to be if something not exactly right goes onto the server? Now this also gets to the commit size, right? If you have small commits that are logical, that are per feature, you're not going to be pushing that to production and all hell's going to break loose. If someone's fixed 17 things and that's getting pushed as one single commit, you're never going to be able to find out where that issue is and roll it back effectively. And then, how fast are your deploys and your rollback? So rollback is essential in that sort of consideration. And so I think if you have a CI server, you can look at the trends. You have QA. And again, I was talking about having a QA person, even if they're only working 30 minutes a day, because that does impact the flow of work through the process. QA people are going to love me for that. That's really important, though, because now you can start looking at some of these numbers and you have a better idea of what's happening on staging. So you review review performance metrics. You've got the clear cost-benefit sort of analysis of production failures, and again, understanding if you're emulating other companies, really understand what they're doing, how they're doing it, what their architecture is, and what their cost is. Sorry, I messed that up. So, increased frequency of deployments. No, that didn't make too much sense there. I missed something. But so here's the bottom point, and this is really what you can take from Japanese sort of stopping the production line. If you're truly mature in your team and process, increasing frequency will reduce production failures because of the demands it puts on your process. So even if you're going through a long QA cycle on staging and then you're pushing to production, if you continually speed things up and you start pushing like 10 times a day, 20 times a day, the sort of accompanying improvement in your process will ensure that you are deploying higher quality code that at a rate higher than would have been caught with a QA staging sort of process. Because there's lots of bugs that aren't going to be caught in a longer term sort of process with less diligence and less skill and less automation. So what to use? So in JavaScript world, so I think we can look at it, we have our stack, our tech stack, but then we also have our process stack, which is a collection of tools and processes. And this has really changed in the last 6 months, especially Yeoman. Like I think a lot of people were about to give up on Yeoman, and then they went from, I think it was 0.96 to 1.0, and they completely changed the entire product and rewrote it. They adopted Grunt, which had been emerging as sort of the standard for an automation tool, Bower, front-end dependency management, and with Node, NPM, Yo, Grunt, Bower, Git, Jenkins, there's an amazing sort of stack where there's a lot of best practices emerging, and it's not that hard to figure out what those best practices are. You just search for them on Stack Overflow and read for a little while, and then you can sort of get a good sense. Just make sure you read the date closely. So Git, Jenkins, Mocha, Karma, Kanban, Scrum. We've been using Trello. We're starting to find that a little bit too simple for what we're doing. It's like, or not simple, and it's sort of in this sort of middle ground. So we use Pivotal Tracker on some projects as well. And then what the commitment is in the organization to the process. If people really understand. So one of the reasons I talked a lot about the importance of feedback and the importance of frequency and entropy. These are all things that people can understand, and if you talk about it and think about it, then you can get to the point where you can be really emotionally committed to continuous deployment, not because it's the trendiest thing and you want to be with what's sort of like supposedly best in class, but you can really feel what the benefit will be, and you really want to drive that excellence in your organization. And so I think that by going through that and looking at some of the sort of the deeper, I knew that was going to happen, so the deeper processes, you can really build that commitment, and it's worth going through that exercise. And it's worth looking at a maturity model process and looking where you are, phase 1, phase 2, phase 3. I think that helps a lot because it allows you to set, one of the key things with continuous improvement is to set immediate goals that are reachable and then get there and then move on. And that's part of what you do with Agile, but also from the broader sort of organizational capability. And so if you can get the commitment, sort of come up with a measurement for a qualitative maturity model, and then start moving forward, then in the space of like 3 to 12 months, you should be able to move your team and your organization into a continuous delivery model that will give you those benefits. So a quick recap, Git is not Subversion. Say anyone who just is starting using Git, they've joined your company or your team, and I know Subversion, Git looks sort of like that. Just sit there and say that to them like 100 times until they think you're crazy, because that'll save you some pain in the future. Training, there's a lot of great training online. Let them learn Git. The magic of rebasing, Git rebase master every day, Git rebase interactive before pull requests. And if you're doing more complex features, you can do an interactive rebase and squash your commits and sort of not have to do a horrifyingly painful rebase when you've got like 74 commits and you've decided you want to commit it. Of course, that really shouldn't happen. If you are getting into that situation, then maybe your feature size is a little bit too big. Sort of the current Git zeitgeist. You have your development branch, feature branches from there. All commits run on the CI server. You've got your release branch, which is staging QA. You do your QA, your E2E tests, acceptance tests. If you can automate those, then you can start doing a flow through directly to production. And then you have your master, which is always ready to deploy. When I first looked at this was so backwards from Subversion, where you have your trunk and then you're taking release branches off that. It took me a while to really embrace it, but actually it's a pretty amazing process. And if you can get this down to 2 branches, all the better. But again, understand why and how and what your unique requirements are. The rebase, so we talked about that. Just in case you're wondering, this little thing here, if this was in the git config file, I would not have set back our master branch 6 weeks. This will stop you from pushing your master. And then git submodules, I'll skip over that. We talked about the git commit message. Lots of commands in git use the top row, the first line is what I should have said there. And so have a first line, a space, so it's clear, and then have a body. And then the body capture the purpose, the boundaries, the intent. Again, this is a fight against entropy. And you're going to have 1 commit per pull request. And even if you are on a small team, even if you're working by yourself, enough time passes and that code could just have well been written by a stranger. And you may be rushing to implement a new feature, and you may not remember some of the intent and design decisions and why you went in a certain direction. And you're going to slowly start corrupting your design because you didn't have enough, information around a particular feature or commit. And so it's worthwhile doing it right. There's some great references on the internet too from open source projects for writing a good commit message. And a lot of the projects have become positively extreme about it. It's like your postgraduate sort of English literature instructor is reviewing your commit messages and making sure that they are fitting the goals of the project and the process. So a couple more things. I think I have 2 more minutes. So how to automate? There's lots of different ways: Bash, Shell.js, Fabric, Capistrano, Puppet, Shelf. Automation-driven DevOps. I thought ADD, but then I thought that might be misconstrued. So got to find a better acronym for that. Write Fabric scripts first, just like with TDD, and then test documentations are implicitly written first when you're following, this kind of a process. Testing the front end, it's like, oh my God, that was impossible until a year and a half ago. And one of the things was that you'd build your whole application on the server. This is where I evangelize a bit, you'll have to apologize. But you build everything on the server, then you want a good user experience, and so you just start stuffing more and more AJAX into your application, and you're duplicating that code. And that AJAX, you're combining data plus HTML plus CSS plus JavaScript, because you're writing selectors that got to find HTML, and you can't find that HTML without changing the CSS. And then when you find all that, you're stuffing data into it. And so you've taken every aspect of a well-structured conceptual model for building documents, and you've completely destroyed it. It's all mixed up. You can't change the data, the HTML, the CSS, or the JavaScript without breaking anything or breaking something. And so the code is born on the server, modified in the client, and you're working against a nice concept of structure and styling and behavior, and you're just completely mangling it to try to get things to work. So data-driven development on the front end has changed that. So I think data-driven development is the thing. And when you do that, you end up with layers. I remember I was doing Angular work, and then I just realized after I got into it a bit more, it's this was getting rid of that sort of hell of breakage, because you can write an application where it's data-driven. You're not pulling any pages, so you're not working against structure. And so you're pulling data. That data is getting consumed by the JavaScript. That's updating the HTML. The HTML is being styled by the CSS. And you've taken something which was this big ball of spaghetti and mud, and you've turned it into this beautifully elegant sort of 4-layer system. And this is now extremely testable, extremely changeable, very flexible. It's really hard to break, which is completely different from my sort of experience with JavaScript previously and jQuery, where I'd write an application using Ruby and Rails, and I'd write all this Ruby code, and then I'd write actually just as much JavaScript code. And so I was sort of really confused if I was, is it a JavaScript app or is it a Ruby app? And the JavaScript code was awful. So half my code base was completely awful, and the other half was nice. And I think this movement to the browsers being awesome and being able to actually architect Now, it enables some of the continuous deployment stuff because you can test a lot of things at a unit level much better than you could previously. And so you're going to get better coverage and better chances of being able to deploy into production. So if you're using Backbone or Angular or Ember, or these other frameworks, the one thing, if you can get rid of the CSS selectors, that enables this more so. So I like frameworks that you can get rid of having to use like a lot of selectors, and you can sort of minimize the scope on the DOM. It's actually very hard to break this, and you can test it. This is sort of like the Bible. It's a few years old, so there's some stuff that's interestingly missing and whatnot. It's funny, when I actually heard of Jez Humble's name the first time, I thought it was actually the name of a new continuous integration server. So I thought there was this piece of software called Jez Humble. But he's a guy who works for ThoughtWorks, and he's pioneered a lot of the stuff in the industry working for ThoughtWorks. A lot of great talks. He was in Toronto. Did anyone hear him talk when he was in Toronto like a couple of months ago? I missed the talk, but anyway, good book. Scrum books, I just realized this the other day. I was looking for what was new in Scrum books, and like every single Scrum book on Amazon.com has a 5-star rating. How's that possible, right? And I just realized it must be really, really easy to write a Scrum book, right? Because it's all cool, exciting stuff. It's all pretty straightforward if you think about it. It's all like, you'll fail less often because you're learning, and it's validated learning and whatever. But it's like there's such a slant to perfect ratings on Scrum books. It's stunning. Check it out yourself if you don't believe me. So I didn't even pick one. I just find a recent book. They all have 5 stars anyway. Like, who cares? So a lot of great JavaScript books coming out. Functional JavaScript came out in June, and sort of how to write functionally oriented JavaScript, which also leads to testability. There's the book Testable JavaScript, Maintainable JavaScript. So there's just, like I was saying, the community around JavaScript is amazing. Of course, I guess this also speaks to the point that people have to write these books, right? Maybe with other languages they wouldn't have to write as many books on writing quality JavaScript. So that might be bad. So anyway, thank you very much. I hope you enjoyed the talk. Sorry, I went a little long, so I got time for one question. All right. Oh, yeah.
There's a little phrase there, recipes over seeds.
Yeah.
So what does that mean?
That's a funny story. Because I used that was in another talk. And so I did the talk, and I was talking about building a stack. And I find that things change so quickly. In seed projects, there's usually 15 decisions, and I'll disagree with 3 of them. And if you try to take a seed project and back out of those 3 decisions and correct for them, it's a disaster. So for instance, if you get Angular seed project and you start trying to remove stuff and you want to use Mocha instead of Jasmine, it becomes really awkward. But there's a lot of cool things happening in the industry. So I talked about how you could actually build your stack using recipes. So there's a lot of good generators. So you can do Yo Angular and scaffold an Angular project. Express, if you do Express in the project name, it'll scaffold out your Express stuff or an API server. And so I was talking about how if you can actually come up with a set of recipes to build the stack, then you understand it better and you can configure it more to your needs. And so I tried to build a stack using best practices and using all of the generators and making the fewest number of changes possible. And so I went on this little rant about how I hated seed projects, and the next speaker had an awesome talk, and he created a little seed project to educate, and it was just sort of funny. But seed projects are great. They have a place, and it was just my rant was a little, I was having a little fun. So that's where that recipes not seeds came from, was part of another talk. So, yeah.
Just a quick follow-up. So then, do you think Yemen is getting better at being less opinionated and letting you have a little more interaction between recipes?
Not really.
Yeah, it's pretty.
It's a hard problem, right? And I think part of that will be if more people get involved in building some of the generators and stuff. So as more of a community and people innovate in that space, I think there's the possibility. But it's a very hard problem to solve, right? I actually was a big fan of the Angular generator for the longest time, and then more recently, I stopped using it. So because we decided to go things like, for instance, feature-based project structure instead of controllers and views and things like that. The grunt script, as we got more knowledgeable on our projects, we became a little more opinionated about how we want to do our build process and whatnot. So, and I think that's a problem everywhere. Like in Rails, you have the Rails standard, and then you have the Rails customized, and most people are on the heavily customized Rails with all kinds of different plugins and things that change the process. So,
Cool.
all right, thank you.
Thank you. Nick Van Weerdenberg, everyone.
Nope.